Imagine a world without the web. No easy access to information. No Wikipedia. No online shopping. Sounds impossible, right? But it was reality not too long ago. In the early 20th century, the world was facing a massive challenge, an explosion of information. People were producing so much data that traditional management systems struggled to keep up. There was a massive amount of information to consume, process, remember, index, categorize, share, and use. It was a case of information overload. Before the web and Google, how did people even know what resources were available? How could they gather the information they needed from so many different places? And how did they connect all those ideas and keep track of everything? For example, doing research meant physically going to the library. Researchers spent hours flipping through books, journals, and microfilm. If they found the right book, awesome. If not, they often had to request it from somewhere else, which could take weeks. It was a slow and frustrating process, right? Many philosophers believed that sharing knowledge globally could lead to world peace, but a big question still lingers. How do we organize all this knowledge so everyone can access it? How can we build a system that automatically stores, summarizes, categorizes, and links information? A system that searches through archives, provides results, and suggests related content. As information increased and old information management systems faltered, innovators began to imagine a worldwide information management solution. This system would store, categorize, link, and search data all on its own. That dream became the World Wide Web. Picture it as a giant digital library full of websites instead of books, with search engines like Google taking the place of librarians. Now, by simply typing a few words into a search bar, you can quickly find information from anywhere in the world. The web has changed the way we learn, work, and communicate. And it all started with a vision and a lot of hard work.
By the 1940s, microfilm technology was commonly used in banks, newspapers, and libraries as a data storage method. To move forward, the challenge was how to automate the navigation between ideas. In 1945, Vannevar Bush proposed a concept that eventually led to the development of hypertext system and the World Wide Web.
Bush believed that traditional information systems, which rely on indexing and categories, slowed down access to information. He recognized the need for a more efficient system to organize information. He envisioned a system that mimicked how our brains naturally store and retrieve information. Instead of being organized by traditional categories, information would be connected by free associations, similar to how the brain links ideas.
To explain this idea, imagine a library stored on microfilm tape. In traditional systems, information is read sequentially, sentence by sentence, page by page. If the current piece of information is related to something in another section, you would have to manually find the relevant category and search through subcategories to reach the target. This process takes time, and every reader would have to follow the same steps.
To avoid this long process, Vannevar Bush suggested a faster method. He proposed linking related ideas through associations, like how the brain works. With one idea in hand, you could instantly jump to the next related idea. This could speed up navigation between connected topics and ideas, allowing readers to directly access related information through these links. With the press of a button, users could move through a series of linked topics.
In 1945, Bush also introduced his vision for a personal device called Memex. The Memex was imagined as a device where a person could store all their books, records, and communications and retrieve them quickly and easily.
The Memex was envisioned as a desk with translucent screens for reading, a keyboard, buttons, levers, and microfilm storage that could hold large volumes of data in small spaces. It would also have a photocopying function to store and link documents. Essentially, it allowed users to store, link, and navigate information quickly. A whole library could fit within this desk, and most of the content would be purchased on microfilm, ready to use.
To link two items, the first item would be displayed on one screen and the second on another. The device would then generate an association code to connect them. The user could navigate through related topics by using one screen to stay on the main topic and the other to explore linked ideas. A keyboard was available to enter numbers for navigation, and with the press of a key, you could follow a trail of related topics.
Bush envisioned this device at a time when computers were just calculators. Transistors hadn't been invented yet, and computers ran on relay and vacuum tube technology. Storage media as we know them today did not exist. Let's take a look at some photos to understand the state of computers in that era.
Personally, I believe that the MEMX vision helped shift the development of computers from calculating tools to personal devices for storing and managing information. Not only that, but it also led specialists to think of data sharing on a large scale over networks.
This MEMX device inspired computer engineers, and the idea of the new information system inspired IT specialists. Later, in the 1950s, the notion of a computer network emerged. During the 1960s, the notion of the computer network, as well as Vannevar Bush's ideas, inspired Ted Nelson to propose his idea known as Project Xanadu. Nelson generalized Bush's MEMX idea from a local desk-sized machine to a theoretical global computer network. He questioned why people should be limited to a local information. How about linking ideas across a global network? He envisioned that individuals could link their local hypertext information to the work of others via a global hypertext network. His global network can act as a decentralized global digital repository where the users can easily browse the masses. These three ideas envisioned the future of information management. This vision was a dream that inspired computer scientists and IT specialists to work on three parallel tracks to make this dream a reality. The dream was born here, and here all the required technologies were ready to turn the dream into reality. In the 1990s, Tim Berners-Lee finally brought the pieces together. He published his information management proposal in May 1990. Finally, the World Wide Web was born. His World Wide Web became the first hypertext tool for the masses. The success of creating a new information management system that augments human memory is one of the greatest inventions in the history of informatics. The World Wide Web has 5 main components. HTML is hypertext markup language. Hypertext is just text that contains hyperlinks. Hyperlinks can be distinguished from normal text by adding this HTML tag. Hyperlinks can be used to link web pages for navigation. Web pages are just text documents that contain HTML code. A web server is used to host and manage access to HTML documents. Clients can access HTML documents using a software tool called a web browser. A web browser provides a useful interface for clients to simplify interaction. Client and server can communicate over the internet. The communication can be managed under a specific protocol called Hypertext Transfer Protocol, HTTP. Now, sharing knowledge is easy. Press a link and go through a trail of ideas and topics.